Romano, I see you're out here working again. What's on your shirt today? What is that?
This happens to be the beta-D-glucose molecule. It's really easy to spot. All the groups are in the equatorial position. But this is not the point of today's video. Today's video is going to be on biology and a very important cell known as the fibroblast. So come over and let's take a look at what I have for you.
Okay, Dr. Romano.
Now, the fibroblast is the principal cell of connective tissue. They're very easy to spot. You can't miss them. They're shaped like discs. I like my pathology and histology teacher. He called it cigar-shaped, and they definitely look like cigars. If you get a chance, have a look at a fibroblast, and you'll see they're very easy to spot in connective tissue. They're most abundant in the periodontal ligament. For you budding dentists out there, you should be very interested in the PDL. It anchors the tooth into the alveolar bone socket. Of all the cells, the fibroblast is the least specialized. You may thank me for this question one day. What I mean by that is these mesenchymal fibroblasts can and will differentiate into a whole array of different tissues. For instance, they can become adipose tissue, they can become cartilage, they can become muscle, they can become bone. So the least specialized of all these cells in connective tissue are fibroblasts. They have a huge amount of functions. For example, collagen synthesis, elastic fiber and reticular fiber synthesis, complex carbohydrates of the ground substance is produced by the cell. Recent research has suggested all components of the extracellular matrix is made by this single cell called the fibroblast. So when you're thinking of the extracellular matrix and the ground substance, you can thank the fibroblast. Under the transmission electron microscope, the cytoplasm exhibits much rough endoplasmic reticulum as well as a prominent Golgi. Now, they respond to a wide variety of cytokines, which allow them to work with the white blood cells during wound healing and tissue repair. I'll give you a good example of what I mean by tissue repair. Dermal fibroblasts, they are involved with active skin replacement cells. They act as active skin replacement cells, and they make collagen. Collagen, as you know, could induce fibrosis. Macrophages also make cytokines, which help activate the fibroblasts. Now, one last point that I want you to understand is you can also, these fibroblasts, just like politicians, they can go to the other side very quickly. Cancer-associated fibroblasts. This is essentially a fibroblast that's a synthetic machine, and it supports tumor growth. So if you looked inside these tumors, you would actually see these CAS or CAF cells, cancer-associated fibroblasts. They secrete cytokines that contribute to drug resistance. There's no apoptosis, and they increase angiogenesis of new blood vessels. And when you're talking about cancer, cancer cell needs new blood vessels to thrive. And these fibroblasts are involved in supporting their growth, as crazy as that sounds. All right, I hope this helps. We got some really great questions in the new issue of the Destroyer on the fibroblast. It's a very hot MCAT, DAT, and OAT type of question and topic. All right, I hope this helps on this topic.
Hey, Dr. Romano, can I give a shout out to my friends in the study group?
Do whatever you want. Good day to you.
Okay, everyone in the study group. Hello. It's a beautiful day. Good day to you, sir.